Hi, I'm Andy and this is question 6 on the AQA Decision 1 paper from January 2007. For more questions on this paper, click the eye in the top right corner. In question 6 we have a rectangular swimming pool. There's various constraints given on the length and the width of the pool, and we're also told something about the cost of the pool. And in part A we need to show that one of the constraints leads to the inequality 2x plus y is less than or equal to 18. Notice that also in part B we need to find 4 further inequalities. So first of all, don't worry if you find the wrong inequality to start with, because you're always going to use that for part B anyway. But for this part, you may be able to spot that this inequality here is going to come from the constraint to do with the cost. So the information that will be relevant for part A is this part here about the cost, and also the information about our decision variables. So x is the width of the pool and y is the length of the pool. So if each metre of the width of the pool costs £1,000, that means that we would do 1,000 multiplied by x to find the total cost depending on the width. So we need 1,000x, and each metre of the length of the pool is 500, that's going to be plus 500y. And the total cost must be less than or equal to 9,000. If we divide everything by 500, we end up with 2x plus y is less than or equal to 18. Now in part B we need to find 4 further inequalities. We'll start with this one here. It says he wants the width to be at least 2 metres. That tells us that x must be greater than or equal to 2. We're also told the length must be at least 5 metres. That tells us that y must be greater than or equal to 5. The next two are the style of inequality that often catch people out. So here we've got the length needs to be at least twice the width, and the length must be no more than 3 times the width. The problem with these inequalities are that people often get them the wrong way round. So you might want to do a little bit of working out to help you make sure you get it the right way round. First of all, let's forget about the fact that it's at least. Let's assume we wanted the length to be twice the width. Well, we know that y represents the length and x represents the width. And let's say we knew the width was 5 metres. To get the length, we know that would be 10, it would be twice. So what we need to do is multiply whatever the width is by 2. Now we'll introduce the at least part again, and that's going to tell us that the length here must be bigger than 2 lots of the width. So we need the inequality to be that way round. So this inequality will be y is greater than or equal to 2x. Very similar, for the length to be no more than 3 times the width, we will get y this time it must be less than or equal to 3x. So for these ones here, to make sure you get the sign the right way round and the numbers in the right place, it's often quite useful to do a little doodle over here and put some numbers in to see if it makes sense. In part C it says on figure 1 draw a suitable diagram to show the feasible region. Well, here are our 5 inequalities, the one from part A and the 4 from part B, and here is figure 1. We'll start by drawing the inequality x is greater than or equal to 2. That's going to be a vertical line through x equals 2. There are 25 squares between 0 and 5, so 2 will be at 10 squares across. And we're interested in the region greater than 2, so we'll shade out the region we don't want. Next we've got the line y is greater than or equal to 5. That's going to be a horizontal line that goes through 5, and we're going to shade underneath that line. Next we have the line y is greater than or equal to 2x. So for this we need to draw the line y equals 2x. That's just a line that goes through 0 with a gradient of 2. A point on that line will be 10, 20. So we could plot that point, and we'll draw a line from 0, 0 up through 10, 20. As y has got to be greater than that, we want to shade out the region below. And y is greater than 3x is very similar. To plot this one, we might plot the point 5, 15. And we are interested in the region that is below this line. Finally, we need to draw the inequality 2x plus y is less than or equal to 18. To draw this line, I'm going to use the cover-up method. I'm going to say that when x equals 0, by covering up that bit, y must equal 18. So that means the point 0, 18 must be on my graph. And when y is 0, 2x must be equal to 18. So that means we get 9, 0. We're interested in the region that's less than 18, so we're going to shade out the part above the line. Finally, in part D, it says use your diagram to find the maximum width of the pool, state the corresponding length of the pool. The maximum width of the pool appears when x is at its largest value, and that's this value here. Now, if you've drawn this line on paper, you may be able to see precisely what this value is, but sometimes it's difficult, particularly if you've drawn your own graph. It's fairly straightforward to find the exact value of this point by solving a pair of simultaneous equations. We've got this line coming down here, which is 2x plus y equals 18. And we've got this line going up here, which is y equals 2x. So if we sub this equation into this equation, we can say that 2x plus y, which becomes 2x, equals 18, which is 4x equals 18, which means x equals 4.5. And when x equals 4.5, y equals 2x, y will be 9. So we can say the max width equals 4.5 meters, and at that point the length will be 9 meters. And that's the end of question 6.